Radar systems come into our shop with write-ups regarding spoking as the reason for removal off the aircraft. The most common type of radar spoking appears on the display as a pie-shaped patch only when there's weather. Spoking is a general term used when a radar system fails. You can determine which part of the system is causing the problem based on what appears on the radar display. This occurs when the receiver and transmitter lose lock and do not track with each other. This will typically appear on a radar display as a pie-shaped patch and will only be present if there is weather to be shown. However, with newer radar systems like the RDR-4000, the most common cause of spoking comes from the antenna and is caused by noise from the sweep resolver, damaged waveguide, or malfunctioning rotary joint. This will normally show up on the radar display as a very thin line that will start at the apex of the screen and continue to the edges, no matter which range you are set on. This will almost always appear at the same spot on the screen, as shown on this video. Here are some examples of intermittent antenna resolver wiring which caused spoking.
Alright, today we're going to cover how to identify and troubleshoot resolver pin failures on antenna drives. Right now we have a good example of an antenna drive that has resolver pins that are bad, and I'll walk you through the steps on how to identify and troubleshoot these. First step is our setup. We have a PC, it can be Windows NT or XP with calibration software loaded on it. Two power supplies, one for 6.5 volts, one for 28 volts, and a test communication cable. Part number can be located in the CMM. So step one, we're going to turn on our power supplies, 6.5 volt first and 28 volt second. Allow the power to come up. So on your computer, you're going to open up the calibration test software, and we're just going to use it in a troubleshooting mode, so you do not have to put the part number or serial number in it. So open your test software. You're going to press next, next again. You need to connect up to your COM port. We're currently set up to COM port 4. And you should see Honeywell ADP H-bit version loaded, displayed on the screen. This shows that you're communicating with your antenna drive. Our first step is we want to put this into a sweep pattern and verify that we have a stable sweep pattern. So to do that, we're going to type in the command go cal 0, then press the send button. At this point, your antenna should start sweeping. And as you can tell, this antenna has an unstable sweep where it's not smooth, and it just has a little bit of jitter and jerk at the end of it. This is an indication that you have a problem with your resolver feedback signal from your antenna, and this is normally associated with bad crimps on your resolver pins. To further validate this, we're going to put the antenna back into a standby mode, then set it to a 0 position. To put it into standby mode, we're going to send the command go standby and hit the send button. Your antenna should stop sweeping at that point. To go to the 0 position, we're going to send the command go cal 3. And your antenna should come up to the 0 position. When it's at the 0 position, you should feel resistance when pushing against the energized motors. On this one, you can see that there's very little resistance in your azimuth, and this is also an indication that you have a problem with resolver feedback. To verify this, we're going to want to get a close-up on this point right here. We're going to take a non-conductive stick or some type of object that doesn't have a sharp point on it, so we do not damage the equipment, and gently manipulate the wires and the rubber stop and the end of the connectors. And if you see the antenna gimbal move off the center on its own, not from pushing it, you're losing one of your resolver signals. There's a break in the connection, and that's also an indication that you have a bad resolver pin. So gently manipulate the wires and the connector. If you see it kind of move off on its own, and it just has to move slightly on its own. If you see it move once, you have a bad connector pin, and you need to replace them. And if you replace one, replace all the resolver pins, because we have found that if we have one, we usually have more than one. And that pretty much concludes troubleshooting and how to find a bad resolver pin. Thank you.